And some of it's why we want to practice for 2 months, so you get better and better at recognizing yourself. And honestly, I don't worry about picking what's easy before I begin. Sometimes I will read a problem and I just can't figure out where to go, so I just skip that. Other times I'll read a problem and feel like I know how to start, so I'll start working. If I get stuck, I move on as well. So the easy ones are the ones where you just start working and, oh, I finished. So it kind of happens naturally. Okay, it says consider the differential equation. Please raise your hand if you can tell me what is the purpose of this equation. We've talked about it a lot today already. What are you going to primarily use that equation for, Jim?
Finding slopes.
Finding slopes on the graph of f. How many knew it? 2 points, 3 for sure. Or the graph of y. Just, it's the DIFFeq chart I showed you earlier, right?
Yeah.
This. They're giving you this. This is for finding slopes on this. Are you with me? So they're giving you this one, looking for slopes on this one. Okay. So back to here. Huge warning. Just because it says consider the differential equation doesn't mean you go and use the SASSY method. Use the SASSY method to solve a differential equation. There's a lot of AP problems where they give you a differential equation, they don't ever ask you to solve it. Like this one. They say consider.
Plug in all of those points.
Yeah.
Really?
Yeah.
You just do like -1, 0, -1, 1, -2, -1, 2. Okay.
You say, let's make a little table here. Okay, so this one doesn't ask you to solve the differential equation. It just says sketch the slope field. A slope field is not a graph. Okay, a graph is a bunch of points where every point represents 2 numbers. A slope field is a picture of slopes. So you are drawing what f would look like. Like what would the slope of f look like at different points? And you want to find a pattern because it makes the problem a lot easier. So look at the equation. Talk to each other and raise your hand. I want to pick a value of, like I want to pick just a single value of x or a single value of y, which when I plug in that value, I can determine several points, not just one. Because it makes the problem a lot easier. If I can pick a value of x or a value of y, which will allow me to do this computation for multiple points simultaneously. Hands up. Don't overthink it. Got all these different x, y values. I want to pick an x or a y that when I plug it into here, the computation becomes instantly easy for multiple points, not just one. Jack?
0.
X or y. Either one. So if I go x equals 0, that would be here. That would be y be 0. That would be here. So 0, 1, and that would be here, 0, 2. If x is 0, you don't care what y is. The whole thing is 0. So that's a really good choice because you found 3 points instantly.
Then you were thinking of why you find 3. You already had 0, 0.
So this time I'm going to go right here. You already have the 0, 0. That's redundant, but like so. Okay, hands up if you had your hand raised. 2 points, 3 for Jackie. Question?
Why do you have 3 lines? Could you just plug in 0 once for x?
So this is the point, x equals 0, y equals 0. A slope field is a picture of, you have to remember, we're drawing what, like it's DIFFeq's chart again. So we've got f, or y, and we've got f prime, or dy dx. We have an equation right here, like that, and we're trying to figure out what this is doing. This is a picture of what this does. So if f goes through the point 0, 0, this is kind of a what if picture. if f were to go through this point, the slope of f as it went through that point would be 0. Does that make sense? It's not your question, though.
Like, how does he diagram those? Like,
Oh, I didn't mean to stop. Is that what you meant?
Like, I don't get how you
No, how would you put it on the graph?
Yeah.
Oh, so the x and the y refer to these points.
Okay.
Like, what's the x, y here?
0, 0.
Stay with me, Amanda. So that's this one, or this one.
Oh, so, okay.
Do you see
I
it
was just
now?
confused on the table.
You good now?
Yeah.
Good work.
Okay.
Anybody else?
How do you draw that it's 0 on those?
What does the slope of 0 look like?
A flat line horizontal.
So you just draw a little horizontal line on that point?
You're drawing little tangents.
Okay.
You're just drawing little tangents. If the graph of f, 1 second, good. If the graph of f were to go through this point, f might look like this. Or f might look like this. Yeah, I could do a little saddle thing, they call it. Like that.
Tangents up there.
Or, you know, f might even do this. You don't know. It's just a what if. Jacob, please.
Do we have to draw the tangent lines, or can we just make the table?
Gotcha. To get the points on the slope field, you have to draw the picture. The table would be considered scratch work. They won't even look at it.
We draw straight lines at values of y too, right?
Yes. Like what I'm doing is right here is the point x equals 0, y equals 0. And I've calculated using this formula that the slope of f at that point would be 0. So this is a picture of what f might look like if f were to go through that point. Are you stretching? Good. Super brief. Anybody else? So then just keep going. 0, 1 is right here. 0, 2 is right here. I'm doing that wrong, aren't I? 0, 1 is up here. Sorry.
That's okay, you're still drawing horizontal lines.
Left out. Let's see. -1, 0 is here. Did that one already, so there we go. Please, no.
We're on the GP test, like, if you're like using a pencil, do you have to draw like your line to stay?
Enough that they can see it.
Okay.
Yeah, they are looking for the drawing. Pretty good? Okay, again, I like to use patterns. So the next pattern I would use is I'd notice that here x is 1, here x is 1, here x is 1. So I'm going to do those. So when x is 1, y is 1. When x is 1, y is 2. So 1, 1. So that's going to be -1 times 1 is 1. So that's going to be -1/2. So right here is -1/2.
How do you draw that?
So so negative slope goes this direction. Here's all I do. Look, you got to line up the dots. You have to draw it accurately. If you are casual, you will lose the point.
Isn't it, would you go 2 over?
So this is a slope of -1. So I need half of that. So I need to go more like from here to here.
How long do you draw the line?
That's good. This one here is going to be, let's see, we're going to 1. It's going to be negative. 2 squared is 4. 4 divided by 2 is 2. So it's -2. So come up here. -1 would be right to that spot. So -2 is to this spot. You have to be accurate or they will take away the point. That's a slope of -2. The slope of -1 would have looked more like this. They have to be able to see the difference. That's enough different, they can tell. So again, I just line up the dots. So I want to go to here, like that. Questions? Just keep going and finish off these doing the same thing. So we only have a minute, so we'll just keep going here. I'll stop. You don't have to draw this. This was just me trying to help you. You don't have to draw this. Did I make a mistake?
No, I just don't know how to draw the ones on the corners because I don't have reference points.
I'll show you. Just take a new reference point. So this is x equal 2 and y equal 2, right?
Yeah, and that's a -4 slope.
Yeah, because negative, so 2 squared would be 4, divided by 2 is 2, times the other 2 gives you -4. You are correct, that's a rather steep. Let's see. If I put the dot here, that's about right for a slope of 1. That's a slope of 2, cut it in half again, that's a slope of 4.
What about on the other side? The other
Positive
corner?
4, yes.
No, it's 2.
This one here? Oh, it's because it's only over 1. So positive 2, I would draw the dot. Again, just get the spacing about the same. Just draw a little reference. So that's the slope of 1.
And if you're not exact on your reference, they're not going to get mad at you,
It
right?
doesn't have to be perfect, just enough that they can distinguish the difference. For example, the grader's going to look here and say, these have to be different. First thing they're going to check for, Jackie, is the positive, negative for sure. If you're the wrong direction, you lose the point. Next thing they'll
And
look at.
it's not 1 point for each one, it's like 1 point.
No,
for
it's
all
if
of
you
them.
look in the back, it's like 2 for the whole field.
So if you mess up 1, you lose
One of the 2.
1 of the 2.
Yeah.
If you mess up
2, you lose all of them.
all of them.
It's not, look. You just make sure you get the direction the right way.
And
Yeah.
ish the right.
I get you. The key thing they're looking for, Jackie, is right here. This is a half. This is 2. This is 4. They're just looking for kind of relative. What are my children questions?
2 questions.
No one talking, can't hear.
For the 1, 2 on the graph, the thing with the slope would be -2.
Yes.
And how do you know it's negative?
So I plugged in 2 for x.
Oh, I did not see that.
Do
Okay.
you see it now? 2 points. Were there any other weird ones? Slopes? Okay. Good work.